Alright, let's look at another example, XeF5 plus. First thing we'll do is draw out our Lewis structure. Valence electrons. We have 8 for Xe, and we have 5 fluorines, and then we will subtract an electron, and that's going to be a total of 42 electrons. Now we're going to go ahead and draw our Xe, and I'll put 5 fluorines around it. How I put the fluorines around it doesn't really matter at this point. It will later, but not right now. And now I will satisfy the fluorines. I've already used up 10 on the bonds. And each fluorine is going to need another 6. Okay, so now I've got 5 times 8 is 40. I've got 40 electrons accounted for. I've got 2 more that need to go on the central atom. To complete it, brackets, and a plus on the outside. So there we go, it's XeF5 plus. That's part A. Part B, we need to look at the overall, and for that we need the total number of electron groups, and the number of electron groups is going to be a total of 6. We've got 5 atoms and a lone pair of electrons. So we've got 6 electron groups. And on our diagram, the one that best represents 6 electron groups is going to be octahedral, so that's going to be our overall shape. Next we will go ahead and look at the shape of the atoms, and for that I'm going to need to redraw the diagram, and it's going to have to look more in accordance with what I see here. And the one that's got 5 atoms and electron pair is this one, square pyramidal. So that's going to be my shape of the atoms. Square pyramidal. So I'm going to go ahead and draw that. Pretty much draw it the same way as I've got it on the diagram. And we'll also put some bond angles on here as well. And the bond angles are all going to, well, these are going to be 90s. And I guess you could also argue that we've got 180-degree bond angles as well between the opposing fluorines. Alright, so that's what we're going to see there for bond angles. Now we can go ahead and look at the hybridization. We've got 6 electron groups, which means we need 6 hybrids. And that means we need 6 orbitals. And that's going to be S plus P plus P plus P plus D plus D. So that's going to be S, P, 3, D, 2. So that's a hybridization on that one. And now we can go ahead and look at the dipole. Now for the dipole, I'm not going to consider the lone pair on the Xe. Just ignore that. And just for the sake of clarity, I'm going to ignore the lone pairs on the outer atoms as well. I've already drawn them once up here, so I don't need to do it again. Alright, so let's go ahead and put the dipoles in. Fluorine's more electronegative than Xe, so draw dipoles along each of those bonds. And you'll see that these will cancel, and these will cancel, and all we'll be left with is this one. So that's going to be the net dipole on the molecule.